Oh, I hear the birds are chirping in the background somewhere. KubeCon is said and done, but today we're going to do a little recap, and I'm joined by my co-host, Job Jackson. Hey, Job.
Hey.
Job's going to pretty much take the helm here, no pun intended, but joining us as well is Cheryl Hung, Vice President of Ecosystem at CNCF. Hi, Cheryl. It's great to see you again.
Hey, Alex. I always love being on the new stack, so thank you for having me on again.
And Bryan Liles, Principal Engineer at VMware. Hey, Bryan.
Hello. Good to see you all.
Good to see you. And so our topic today really is a recap of KubeCon. And there was a lot covered at KubeCon, and Job was there pretty much following the whole show. GitOps, policy as code, data management. There were lots of topics there. I was interested in a few topics, the dev experience in particular. And it's been interesting for me because the dev experience, I've had a little bit of a new thinking about it in terms of what's a dev experience like in a very complex environment? It just can't be just about simplification. So I'm going to turn it over to Job. Job, over to you. That's my thought on dev experience, but there's other topics as well. Job, take it away.
All right, terrific. So let's dive right into the questions with Cheryl and Bryan. So yeah, we saw a lot of interesting things, as Alex mentioned. The developer experience was one of them, and also the proliferation of runtimes. There's some interesting talk going on there. So what does it mean? I guess when we talk about the developer experience of Kubernetes, I myself am a bit confused because I was assuming that developers themselves shouldn't have to deal with Kubernetes at all if it's set up properly. But at the same time, I guess if they want to take advantage of some of the capabilities, they should know about them. So, I mean, where is CNCF and all the contributors at in terms of refining the developer experience, or what is the sense that you get from this conference on the latest on that?
I can start. So first of all, I'll give a bit of my personal background or bias, however you want to call it. So I think that Kubernetes is fantastic, but it is so complex and it takes such a long time to get ramped up on it. To understand everything that you can do and to do it correctly is actually very, very tricky. This is the same thing that we saw back in when I was working at Google as an engineer on Borg. There was this saying that it would take you 6 months to run one thing, and then a minute to run 10,000 of it, because you'd have to spend 6 months just learning how everything worked, how Borg worked before you could even run one application on it. But then scaling was super, super easy. So I feel like we've inherited a little bit of the same feeling within Kubernetes, where it takes people 6 months to really get a grip on it. And Bryan, maybe you agree or disagree on a 6 month
period. Yeah, this is definitely one of those topics where it's like, it's hard to say, or it's hard to swallow the truth. So I'll just take this back just a little tiny bit. Kubernetes gives you this API service that allows you to run workloads on commodity hardware or in the cloud, and it takes care of networking and scheduling and security and a few other things. And I guess the assumption is it does that. It should be easy to just describe your application and deploy it. And like Cheryl said, it took 6 months to get things up and going in Borg, and for one thing up and going in Borg, but after that 10 minutes to get it 10,000. Kubernetes kind of suffers from the same problem, but I don't actually look at it as a problem. If you understand what Kubernetes is actually doing for you, you can respect that, and you actually are grateful for it. But the problem is that Kubernetes success has made it so easy for people to spin it up on the cloud that they assume that the ease of spinning up the clusters should match the ease of deploying. And unfortunately, there's no way. But people are realizing that. And this is where this whole developer experience angle is popping up, where we're learning these patterns. They didn't exist in a lot of cases, like outside of places like Google and Facebook and AWS, because no one has that scale. And now these patterns are popping up, and people are thinking of new paradigms of how to deploy applications. You know, and I'll just say this one last thing. This is great. This is actually perfect, because if we were naive enough to say that, oh, we just got this on the first time, you know, that would have been an awful place to say. This is a very long journey, and we're making continual progress. So I like it.
Nice. 6 months though. Wow, that's a lot of learning. Now I've seen some discussions, back channel discussions about the idea of, I guess, creating abstractions from Kubernetes itself. And forgive my ignorance if I'm not getting this correct, but I mean, there are efforts like Crossplane and Jason Tabaris he had a talk at KubeCon about how he created a minimal Kubernetes style API server to build CRDs into standalone apps. And some people are saying, well, this is a great idea. Well, other people are saying that, no, you don't want to abstract Kubernetes yet again. This should be a choice that every individual developer would have to make for their own application. I mean, is this, am I correct in assuming there's this kind of discussion going on here about abstracting Kubernetes itself and whether or not it's a good thing?
Go ahead, Cheryl.
I would definitely say this is a topic of discussion that I've seen come up across quite a few different end user companies. Typically at the beginning, a lot of them start with, you know, we'll just hand developers kubectl and that will be it. And they can do whatever they want. At some point they go, oh, no, we're actually going to rebuild our own abstractions on top of it because kubectl gives too much access, too many controls. Right. And then a year later they go, oh man, like having to maintain our own abstractions is now a hassle. People can't look up things in public documentation. It takes us, you know, we're always behind the public Kubernetes releases. So then they kind of find some middle way between these two extremes of like pure vanilla Kubernetes and having to do an abstraction which is purely proprietary and in-house.
So I have lots of thoughts about this. So Jason Tabaris is an old co-worker of mine, and he works at Equinix now on a project called Tinkerbell. And I like the way he thinks. Months ago, I started on an effort where I look at Kubernetes and I say, you know what the best part about Kubernetes is declarative API. And it's an extendable declarative API, which means that I can just say what I want the cluster to do, and then something inside of the cluster makes it happen. I don't have to understand anything about that. And then I can create my own types. And if they have their own machinery behind it, I can actually add anything. And that's where like Crossplane and what the cloud providers are doing with their abstractions, it's amazing. But, you know, there's two things here. And there's actually two different approaches to this. So with Jason, he has something called, I think they're calling it the bad idea and the tire fire.
Yes.
And what it ends up being is, it is the Kubernetes API. So all the semantics you expect from Kubernetes API, but there's no Kubernetes, there's no workload management behind it. I've written this 3 times. He has a version that he's working on. And why is this great? Well, now I can create these declarative type control plane APIs, and I don't need to create all the machinery myself. This is actually amazing. And now I can control everything. I actually wrote one, these lights that are lighting me up right now, they can be controlled with a declarative API. That's amazing. And there's another way of looking at this too. And there was a lightning talk, I believe, about this idea of extending the Kubernetes API. But now, instead of, this is the KCP project. And what KCP is doing is they're saying is that we can actually put a Kubernetes control plane abstraction in front of our Kubernetes control plane, and anyone hitting this will think it's their own cluster. So think about multi-tenant situations where I have different versions of software installed inside of my cluster. Well, now we can just install them into their separate tenant, and now we can have multiple versions of the same thing, things we cannot do in Kubernetes. And now we have a different security boundary. This is amazing. Actually, this is the testament that if you want to get me about preaching about Kubernetes and why the idea is great, this is it. The API, because of the way the API works, we can put abstractions in front of the API and they look like the API. All your tools talk to it, but what is it talking to? Well, who cares? It's Kubernetes behind a facade, but now we get all this goodness and now we have all the stability and the world doesn't have to worry anymore. This happened before in the Linux world where where we have like the POSIX or we have POSIX and we have the Linux ABI. And people were able to change this and input behind it. Think about WSL from Microsoft. Same exact thing. And now what we get is things we get an interface that we are comfortable with, that we know how to code against. But what's the back end? Well, who cares? And now we can put this in front of anything. And now we don't need the abstractions like what people were trying to do with like KubeVirt and things like that. We can actually do some really amazing things and use all of our same tools. So now that ecosystem can grow and this other backend ecosystem can grow separately. And we just get better and better over time. This is amazing. Actually, it's funny, Jason submitted this, the next in-person KubeCon. I actually have a demo. I was going to submit it for the next in-person because this is the next groundbreaking idea that we have here.
Wow, my favorite quote from the show too was Alex Ellis saying, "I can't believe it's not Kubernetes."
Yeah, it's going to take a while for it to catch on and for us to have great implementations, but this is amazing what we've done here. We basically made something new without changing anything on the front end. Oh my gosh, that's pretty crazy.
Nice. Well, thank you for that testimony. That is very elucidating. Let's flip over to the other side of this question and talk about the new runtimes. The CNCF SIG runtime co-chair had a great presentation where, in part of it, he was talking about the new runtimes. I guess they're being considered by the Cloud Native Computing Foundation, or they're in the mix anyway. And that includes, Sysbox, which is, I guess, containers as VMs, Crustlet, which you can run WebAssembly on Kubernetes. We'll talk more about that later. And even Trowel, a container storage registry. I guess, well, let me back up. Why are these additional runtimes important to Kubernetes, and how are they helping things, basically?
Oh, wow. These are a whole bunch of really good questions. But Cheryl looks like she has something to say, so I don't want to take all the time. Please go.
No, I was going to actually say I'm going to defer to Bryan
on
this one, because I'm actually interested to hear what you think.
All right. So why are these runtimes so exciting? Well, let's think about what the runtimes we have now and where we started and how and where we are. So back in the day, ancient history, we had the Docker runtime. And what does that mean? Well, Kubernetes could run containers. Yeah, that's pretty neat. And then over time, that became libcontainer. And then we had people like Intel thinking about Clear Linux. And then they made that as a runtime. Now we get the security provided by Clear Linux. And then if we go a little bit further, you have the VM segregation stuff that Amazon and Google did. So you have Firecracker and gVisor. And now think about it where you have workloads that are running, they look like containers, but they're backed by VMs. And actually, I work at VMware. We did the same thing. We have some concept called the CRX and pod VM, where you create a pod and it looks like a pod, but no, it's a virtual machine that launches in 200 milliseconds. And now we see that, there's a backend where we can back it with WASM. So now, whenever I want to run my workloads, I don't have to worry. I can just deploy this, and I know that I can run WASM right here, and it can be optimized, and we can optimize on that bit. So the ability to have multiple runtimes just increases the diversity of what we can run in our ecosystem. Because what we did is we started off just thinking we're going to run apps. I'm going to deploy apps over nodes. Then clusters got big. You got people like Alibaba who are saying, we can run 5,000 node clusters. That's amazing. And then you have on the other side, you have people like Rancher who did K3S, which is the whole thing inside of one, which is inside of like basically one set of processes or one process in a lot of cases. But this runtime diversity allows us to basically tailor Kubernetes to the workload at hand. So if I'm running in the edge, and the edge is something people love to talk about right now, but not in a data center, whether it be in a store or out near a telephone pole. These are different, and we need different semantics for being able to run these applications. We have different security concerns. We have different processes running in them. It's amazing that we can actually tailor the security and the application runtime to what's actually being run. And I'm happy to be able to see that we're seeing all these things. And guess what? Like I said before, this is the power of Kubernetes. This is why we stick through the pain, because guess what doesn't change? Kube apply is still exactly the same. And whenever you run applications that are, your deployment, whenever you go through your deployment, and I'll get a little technical on you. So when you go down there and you define your template spec, and you're actually going in there in the containers and defining those, you know what? It looks exactly the same. But what is it running? And where is it running? Well, it doesn't matter anymore, because as the developer, you want to know, but you shouldn't be burdened with that. And these runtimes allow us to remove the burden of what's running and how it's running and where it's running from the developer. Yes, Alex.
Yeah. I think about, all that you're saying, Bryan, and all these, new runtimes and K3 and, and running things on a telephone pole and the security issues that come with that. And my question for Cheryl is, what were your conversations with the people who are the end users out there? Everyone's an end user to some extent, but the people who are building in Kubernetes into their overall infrastructure.
Mm-hmm. First of all, I'd like to definitely reinforce what Bryan said about the fact that developers really should not care about the heterogeneous environments or runtimes that their things are working on. Like, it really shouldn't matter. And that's a really, really nice property to be able to have on your infrastructure. Secondly, I think my impression is this is still really early. It's really, really early. I haven't really seen a lot of large deployments, really even many production deployments at this stage. I would argue that we're still, the work that Bryan is doing, for example, within VMware is super important to this, but I feel like we're still some point away from seeing it widely used.
That's a good point. There's a cliff somewhere, and there's an edge to that cliff somewhere, and we don't know where it is. So we're prodding and we're poking, trying to figure it out. And what we're seeing now is a lot of exploration and experiments, and a lot of it will fail. But what comes out of this will just make us bigger and stronger. And my argument for that, or my proof for that, is that we never question why we use Linux anymore. I remember the days where we questioned, should we use Linux? We don't question that anymore.
Totally agree.
I just want to remind, before Job, you ask a next question, I just want to remind people who are watching that you can ask your questions. Please leave them in the comments on YouTube. On LinkedIn, you can also get involved in the conversation. So please ask away or provide your own commentary. We'd love to hear it. Job?
Terrific. Yeah, I did notice that eBPF is now Microsoft is now putting eBPF into Windows. So to Bryan's point, I think even Windows is becoming more and more of a Linux kernel these days.
So, that's great. It's funny that, eBPF, what does BPF stand for? Berkeley Packet Filter. And it's funny that, Linux, definitely in the Linux world, they actually created this because they didn't have, they liked what the BSDs were doing, and they created it and they moved it so far beyond, and now Windows is getting it. And who's suffering right now? Like, what BSD that is prevalent out there that actually can't take advantage of any of this goodness? The Mac OS is BSD. And it's funny that we basically made a whole circle around this. But I think over time that we will see some of the Berkeley Packet Filter, and we probably should expound on that just a tiny bit, tell people what this is about.
Oh, please. Yeah.
this is a way that we can basically set up filtering at the kernel level, so we can specify in the user land that we can have filtering at the kernel level. So that means we can have very fast filtering for things for like networks and other pieces of data that we have built up. And why is this great? Well, it's about security, and it's configurable, and there's an ecosystem of tooling that's being built around it, whether it become from networking or security. So this whole term, I think at the end of this year, so next KubeCon, we're going to hear a lot more about BPF, and then in the next year, it's going to start exploding. We're about time. It's ripe.
Yeah, one of our, we just recently wrote a story that, NetData Cloud is using eBPF to monitor Kubernetes clusters in real time. So it just seems like it's just the start of a lot of great technologies, cloud native technologies that are going to come from this. Something else we noticed at KubeCon is a prevalence of WebAssembly. And again, this started out, I wouldn't say as something entirely different, but I believe it was first written for the browser to allow you to, I guess, give you a virtual sandbox within the browser, but now people are taking it and using it on the server side as well. And, maybe we could take a step back and explain why WebAssembly itself is of interest to the Kubernetes and the cloud native community.
Again, I think I'm going to defer to Bryan on this one.
All right. So
because I know it at a very shallow level, but I feel like Bryan's going to have a better answer than I am. If that's okay with you.
Yeah, it's fine. WebAssembly is an interesting thing, like you said, Joe. That that WebAssembly was the thought that we could compile our applications down to this format, and we could run them in our browsers. And I think the idea is that we could get these crazy games, and all the early demos were these huge games that are running in the browser. That's not really interesting to us in infrastructure land. But what is interesting is WebAssembly as a format for running random applications. And the neat part about this is now you're getting more languages like Rust, Go to the certain level, JavaScript, and then I'm sure for C++ and a few other major languages, you can actually take your language and instead of compiling it down to, let's say, if you're using GCC to IR to be linked to something that can create machine code, a binary for your machine, no, you're actually linking the binary is the WASM itself. So that means that, guess what? It's portable now. It's the premise of Java that we had back in the 90s where, write once, run many, and WASM is actually showing us that we can do this. And that's why companies like Fastly and Cloudflare are allowing people to write applications that need to run at their CDN sites on the edge in WASM because they can write it in what language? What does it matter as long as it compiles down? And that's why we're seeing it. And this is also tying into the upsurgence of Rust right now. People are starting to really like Rust as an alternative to C++ or even Go in some cases where the code is fast, there's no VM, and you get memory safety. So all those things where there's not going to be any buffer overflows or underflows in Rust, knock on wood, because of the way that it manages memory and the way that it forces you. And it's not a super hard language to write. So that's why we're seeing this whole WASM thing, and that's why it's so important. We basically have been able to, whatever language you have, we can deploy it anywhere. We don't care about that anymore, which means that we can also optimize for it. So we can have our WASM JITs, and we can optimize for things in ways that we could not if you deploy your own binaries.
Terrific, fantastic. Now, Cheryl wrote an excellent piece in Tech Beacon about 4 things to watch out for at KubeCon. And one of those topics she mentioned was GitOps, which I do believe came up through the Kubernetes community. Weaveworks, I know, is a big company, a big proponent of this. And my basic understanding is you put all your configuration settings and changes in Git, and when you push it out, then you can have a mechanism deploy those automatically. And this was a good idea. And like all good ideas, there seems to be a little bit of discussion about where it works well and where it doesn't work well. I know maybe for multi-cloud GitOps, some people have said, well, maybe this isn't the best approach. It also still has some issues to go with modern CI/CD systems. But let me ask you, Cheryl, what do you see as the promise in GitOps, and what was your takeaway after the conference about its current state?
I'm really excited about GitOps, actually. I think that you get some extremely nice properties out of being able to have all of your infrastructure declared within Git and having that audit log and traceability backwards. So I think that GitOps is something that, honestly, I've actually only really seen good opinions and good feedback on it. I actually would really like to hear a little bit more about some of the downsides, not downsides, perhaps the areas where it's not quite as well developed. Because on the whole, I think I've actually heard pretty much every deployment I've heard of it. I've heard really good things.
Oh, nice. All right.
Well, I thought I have heard some criticism about its usefulness in multi-tenant environments, or when you're using in kind of multiple cloud services. For instance, if you were on-prem, using it on-prem or in a, through a managed service, and then being able to then, keep them isolated and the namespaces separate. That seems to be something that I have heard is a little bit of a challenge. And
I think also with multi-cloud, there's the issue of, I guess you have to create multiple repositories, which may be certainly a time sink.
So
I could see that, but is that better than the alternative? Is that worse than the alternative?
Yeah.
I don't know.
I would actually say the next. I would say there's two bad things about GitOps. Two.
All right.
One, Git. Git is great, but Git takes but knowledge of Git assumes a certain level. Like we use Git and we're fine with it, but Git is esoteric and hard to use, and most people only use like 4 or 5 commands with it ever.
That is true.
That's a barrier. The next problem with Git and GitOps is we don't have a great reference implementation that is not associated with a single vendor. And don't get me wrong, I love Alex Richardson, and because Weaveworks, he's the CEO of Weaveworks, and they actually created this term and pushed these ideas out, and they had a tool called Flux. And they realized that over time that they learned, and now they have Flux v2. And then we have tools like from Intuit, like Argo CD,
right?
And they have their own take on it. And then and then of course Spinnaker is going to want to get in on it, and they're going to have GitOps. And the problem is now we turn this term GitOps into it just depends on who the vendor is. And that's the other downside, is that it doesn't mean one thing. And I want it to be like Git. It means one thing. And we're not there. But this is great though. And I will say this about everything. Everything's a learning exercise for me, is that we figured out that this is important. And now we have multiple ways of looking at it. And now what we're distilling out are the best practices. And, Git came out of BitKeeper, which came out of Linus's frustrations with something else. We didn't just get to Git.
Right.
So we need to just realize that this is a journey, but it's way better than it was. Way better than it was.
I have a question. Go ahead. Go.
So I would argue it's a very fundamental part of cloud native that we actually don't have a single solution for any given problem. We do come up independently with a lot of different solutions, and then sometimes the best thing wins. Sometimes there are multiple things that end up working parallel. That's okay. I think this is actually a good state of things, rather than saying there is only one perfect solution to every problem, which I just don't think exists.
There's a little bit of a paradox there, though, isn't there? Because one thing that Bryan said earlier in the conversation is how Kubernetes has just become, it's boring. You can just depend upon it. You don't have to worry about it. But I guess there was, competition several years ago between it and Docker Swarm and Mesos and the rest. So,
yeah, 100%. And I think it was surprising not, well, perhaps surprising is a bit too much, but I don't think people necessarily expected Kubernetes to be the sole winner out of that race. But that's okay. I think that's just the way that the market and the community has worked.
Yeah. So these are not bad things. Let's get that. When I say that there's downsides, they're not bad things. It's just there's the other side of using this, and I think that the way we're moving is great, and it's better for everyone that we are proceeding in this way. There should be no more I push software directly to my cluster. No. We need to have some kind of governance and provenance around this, and this is helpful.
And I would suggest to anybody who's interested in GitOps that there is the GitOps working group where multiple vendors and people from different companies can come together to talk about what these best practices are and figure out if there are some good or common solutions to certain problems. So I would recommend checking that out.
Yes, and I just got pinged that Stephen Augustus, the coach, one of the co-chairs from KubeCon this year, is now watching. So we have to be on our best behavior.
Oh, good.
Well, let's talk about the edge. It's something that's been bubbling under in the communities, in the Kubernetes community for a while. And I tuned into one talk about ACRI. It's a Microsoft open source IoT project to make I guess you call it an edge resource interface, like CNI's a container network interface for, and in this case, it would be to automate the finding and provisioning of remote devices on the edge. And I know, Cheryl, this is a topic that is also near and dear to your heart. What did you see at this particular show that kind of moved the needle forward for you?
That is an excellent question for which I'm currently drawing a blank. It's a bit embarrassing, but
I mean, edge is always, I remember 2-3 years back when everyone was talking about edge, but it seems to be growing significantly in the Kubernetes community. And there seems to be more use cases where Kubernetes would be, people are looking for a Kubernetes interface for the edge, I guess you could say.
Yeah, I would definitely agree with that. I mean, again, this is sort of Bryan's wheelhouse in a way, but I would say that there is, from what I've seen, there is again, this is pretty early. I would definitely caution people that this is something where we're still trying to figure out what that technology looks like. And I'm not yet seeing any widespread production deployments or use cases of it. But I agree, it is definitely up and coming. It's been bubbling for a couple of years now. And again, the CNCF has a couple of working groups around this, like the CNF working group, where I would recommend people go and look if they are interested in this area.
Oh, wow. So I'm sorry, Alex.
Go ahead, Bryan. Then I'll have a question. I want to have a follow-up question for Cheryl about decentralized storage, because this is an interest of mine lately.
Okay. All right. Well, I'll just talk about edge. And edge is a interesting thing. So there's multiple types of edge, first of all. So you go down to your local store and they have a small computer working in the back that does point of sale. And that could be edge because it feeds back to some main site. And then I work in telco, and we have multiple types of edges. So you have the computers that are near the cell phone towers. You have computers that are a little bit further, but maybe multiple. And then you have like regional, like that, your edge. And then you have this idea of IoT, where I want to attach all these 1,000 devices to my Kubernetes clusters, but I don't want to attach them as nodes. But I still want to manage them and send them information and schedule workloads on them. And this is that edge where, like that ACRI project, and there's a couple more out there that are actually, how do we provide a translation layer from this cloud native space to this IoT space? And I'm actually going to, I can't say that I coined this, but I'll coin it outside of this meeting that I was in the other day. We have this cloud native thinking, but we're also going to need this edge native thinking. So like this edge native thinking is similar to cloud native, but the parameters are a little bit different. And we're going to have to start thinking about this. Like, how do I take 1 million devices and then actually manage them and then schedule and get data back from them? And this is an exciting place. All these little devices out there, you know, if you're running these Home Assistant devices or anything else, you know, this is a whole brand new space. And if any VCs are out there, you know, pay attention to this, because this is actually, this is the next area. We've gone years in the cloud native, but this edge native thinking, woo.
It's so cool.
I heard that the fragmentation in the IoT space is just awful. I mean, if you're a developer, you have to work for each individual end device in a completely separate way.
Yeah, I wanted to ask Cheryl about the decentralized storage story, because I know you have a background in storage, and we were talking before we went on air about latency and how we're getting to this point where latency, you know, if you're in a decentralized environment, becomes just paramount. And you know, there are some projects inside the CNCF, I know, that are starting to look at these issues. And I'm, you know, one of our sponsors is Storage, and I just love what they're doing. You know, this whole idea, I mean, it goes back to your own lab that you have in your home, Bryan, and like how you can, you know, basically you could have an edge network right there, you know, or you're starting, I'm sure you're playing around with those kinds of things. But Cheryl, you know, you come from the storage space. This must be a fascinating time for you.
It really is. It really is. If anything, I think I was probably over optimistic about it, because I got into storage in 2017.
Right.
And I thought that running cloud native storage would be a solved problem within about 18 months. I think that I was very optimistic. We're now in 2021, and I would argue we're still not there. But we've made huge, huge leaps and bounds, come on a long way in the last few years. I think people have gone from thinking that, you know, you can only ever run stateless applications, anything else, don't even bother, don't even think about it. So now where it is possible to run stateful applications and have all the properties that you expect of kind of enterprise storage within Kubernetes. And part of that is due to the CNCF projects in this space. But one thing that I do find interesting and different about storage is that the vendor play is a bit stronger in storage compared to compute or networking or some of the other topics. I'm not entirely sure why that is. I suspect it's because storage is actually just a hard problem. It's one where the risk of failure is very high, because, you know, you can't really drop 1% of your data and be happy with that. So there's a little bit more need for, you know, vendors to provide products and to provide support around it that people can rely on. So I do think this is an area that is super interesting to me. I think it's one that is not as far as advanced as I expected it to be, honestly, by this point. But what I'll kind of be optimistic and on a slightly more positive note. The one thing that I feel has always had a mixed reaction about Kubernetes is the potential for multi-cloud. And I feel like multi-cloud is getting a little bit more feasible, but the multi-cloud storage is still a really interesting problem and a really difficult problem. And when that is solved, I think that is when multi-cloud is going to become really, really, really truly exciting and much more widely adopted.
Is this because cloud providers like to charge for data egress?
That's only part of it. Moving data around is
yeah.
expensive and takes a long time and comes with a lot of risks. So people don't like to do it very often.
It reminds me so much of debates we have, you know, in a data center or, you know, in our own municipalities about traffic and congestion and the geometries of traffic and congestion and how those geometries almost seem illogical when you think about like, well, we should just build new highways. Well, those highways take up a lot of space, and the more and so you're just going to need to build more highways because you're just going to need to kind of support the highways, and
Right.
and so the decentralized kind of argument to to highways might be, well, let's let's focus on reducing the number of highways and bring it in, traffic into other areas. And that seems kind of part of the decentralized story that we're hearing in these P2P environments where, that was basically, this is going back to like the days when a decentralized decentralized network really was the power and the glory of the internet. And now we have this new world that almost demands it again. And I don't know if that goes into your thinking, Bryan, when you're thinking about this stuff, but I'm sure you have a different philosophy about it. But maybe we could just finish up on kind of your own ruminations and Cheryl's ruminations as we kind of conclude this discussion.
Okay. Well, I wanted to talk about one very interesting thing that has came up in this KubeCon is the proliferation of ISAs. And people are like, ISA, what's that? And and basically the instruction set for an architecture. So we're used to x86 64. That's where we are right now, or ARM, or the AMD stuff.
Yeah.
Or we talk about ARM 64. That's popular right now. Raspberry Pis, and then actually what Graviton, what AWS is doing. And then there's another very interesting one that's been popping up, RISC-V. Good old RISC-V. And like and people are like, what is that? And why is that? Yeah, why is that? Well, this is very important. For years, I came up in times where Unix didn't really run on, well, it did. It didn't really run on the x86 platform. There was like BSDOS and there was Sequence, and those were a little bit different. And then we got Linux, and basically we got Linux and FreeBSD and NetBSD, and we showed the power of the x86 platform. And then over time they changed from their CISC to their RISC, and they didn't break anything, nothing big. And we've just been moving in this direction, and the instruction sets are getting larger, and we have all this cruft. And then you had people like ARM, and ARM came up, and they've been moving, and now they have ARM 64. And now we can deploy workloads to ARM servers, and power versus compute, they're actually very, 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 very good compared to x86. And now you have this RISC-V, and now there's a third big one out there. And friends of mine, they talk about it. They bought all these kits, and they're like, this is the future. And what I like about it is we are still able to develop and create all these amazing things, and we don't have to align on one architecture. And this is big, and it's coming up in Kubernetes, and it's coming up in other places in their cloud native space. And that's the neat part about cloud native, is that we're cloud native. We're not, architecture native. And I love that we're able to actually look at these things. And that's probably the most exciting, so basically it was the ways that we can use the API and these new form factors that we can run on are the most exciting parts for me. So that's what excites me these days.
Are you seeing ARM in the data center? Is it do you see a shift moving in there?
Oh my gosh, yeah. Yeah, big time. People, I know companies are talking about moving their workloads to ARM, and they're just saving money. And that's crazy. And
Nice.
Shout out to Intel for, long run, but ARM is coming, and I want RISC-V to come too, because as a consumer, this is better for all of us. We want competition. When there's no competition, we get stagnation. And Kubernetes, like Alex said earlier, when Kubernetes came, there was Mesos and there was Docker Swarm. And I saw it from the beginning that their API was going to kill it out. Mesos had 2 schedulers. Docker Swarm just didn't feel like it scaled. And the competition made it better. And now on the hardware level, competition is making it better. We love this as consumers. Now, for us working in this, it's gonna be awful, because we're gonna have to figure out how to do it. But it's only going to be better for us over time that we are actually doing this. and not defaulting to Intel for everything.
Good engineering is not free.
I love Ralph. Thank you, Ralph.
Well, Cheryl, want to bring us out?
Sure. I want to take a slightly different tack because this was my 11th KubeCon, which is slightly crazy to think about it. I think one of the things that I really enjoyed about this particular KubeCon is the fact that we made a specific efforts to bring in people who are kind of beyond the core set of people who already know about cloud native. So for example, students had their own track, and we had a track for business people as well. So I feel like cloud native is really expanding as a community. And again, more diversity is good, more choice is good, more people is good. That's how you get that productive clash of ideas and thoughts that means that I'm excited to go to my 12th KubeCon, hopefully in person. Fingers crossed.
Woohoo!
Dun, dun. Sweet.
Hell
All
yeah.
right. This has been great. Thank you so much for joining us, Cheryl and Bryan. I love the perspectives here. I could talk about this decentralized storage world for a long time. I'm just so fascinated by these issues about latency and the edge and such. And it's really going to be the direction, I think, where we're going to see a lot of developer experiences emerge, as going back to the original part of that discussion. So thank you so much. And Job Jackson, thank you once again for being a co-host on the show. We are through with KubeCon. May we meet in person in LA. Hope to see you there. It should be fun.
Definitely.
All right.
Thank you so much, all.
That was great.
Yes.
Good stuff.
Thank you.